Hi, this is Ms. Pellegrin, and today we're looking at Module 2, Lesson 8, Applying the Properties of Operations to add and subtract rational numbers. So today we are looking to use properties of operations to add and subtract rational numbers without the use of the calculator. So we're just going to be looking more in depth into adding and subtracting rational numbers. Okay, so in example 1, we have the opposite of a sum is the sum of its opposites. So we want to explain the meaning of the opposite of a sum is the sum of its opposites. And so we're going to just take a rational number, like 7, and another rational number, like -2. And so their sum is 5, and the opposite of their sum would be -5. So then we're taking the opposite rational number. So we had the rational number 7. The opposite of that is -7. And the opposite of the other rational number, which would be +2. And their sum would be a -5. So the opposite of a sum is the sum of its opposites. So we're taking the opposites of the numbers and we're getting that sum. So it means if you had the opposite of a sum, okay, so sum meaning adding, and then opposite on the outside of these parentheses, you can rewrite it as the sum of each addend's opposite. So the opposite of +7 is -7, and the opposite of -2 is +2. So these two things are the same thing. You might notice this as being the distributive property. We're going to use and say the opposite of a sum is the sum of its opposites currently. Okay. So, exercise 1, we want to represent the following expression with a single rational number. Okay, so in other words, we are adding this together. And it is an exercise, so you're just going to pause the video and try it on your own. Okay, so the strategy that you might have used might have looked similar to this. You took and you changed mixed numbers to improper fractions. So, and then after that you might have changed, so maybe let's put some steps here. We changed mixed to improper. Then we made common denominators. And then here we -48 and 65, they were different signs, so we subtracted. And then we did that again. And that's how we got our answer. And we simplified. Okay. So what we're going to look at is we're going to look at another way that you could have attacked this problem and worked on this problem. So we could have looked at it and we could have said we had -2 and 2/5. So here's my problem. negative 2 2/5 plus 3 1/4 plus a negative 3/5. And I could have used the commutative property. Write it out to the side, I just don't have the room. To reorder it and say negative 2 2/5 plus a negative 3/5 plus 3 1/4. And then we have our fifths together, so we could have said negative 2 and then 2/5. 2 plus 3 is 5, since they're both negative. Negative 2 5/5. And remember, with our commutative property, when it's addition, we can move it around. Plus 3 1/4. Negative 2 5/5. Well, 5/5 is 1 whole, so that's a negative 3 plus 3 1/4. And if I have a negative 3 and a positive 3, well, those cancel out, and so all I am left with is 1/4. This may not be the way that you have tried. You might not have been exposed to it before. And so we're gonna look a little more into this. Maybe this was an easier way for you to be able to move it around, and then you didn't have to make those common denominators. Maybe you're feeling comfortable with sticking with the way that you know how to do it. Today we're going to try and get you a little more comfortable with using the way to the right. So, you will not have to use the way to the right. You will have the option, but we're just trying to give you a different option so you can see different ways to add rational numbers. So, in example 2, a mixed number is a sum. We are looking at it to see how we could rewrite it using addition. So 2 2/5 means, this 2 2/5 means 2 plus 2/5. So you have 2 wholes and then you have 2/5. So therefore the opposite of that, so that's why they have the parentheses, so the opposite, negative on the outside, the opposite of that would be 2 plus 2/5 with that negative sign on the outside. So it would be negative 2 plus a negative 2/5. These two things mean the same thing. So negative 2 2/5 is the opposite, so write the opposite of 2 2/5. So negative 2 2/5 would be your opposite. So how can we show the opposite of a sum is the opposite of its opposites? And so that's what we're doing here. This is going the same distance as if we went to the left. So 2 wholes and then a little bit, the 2/5. And then here we would have negative 2 wholes and then negative 2/5. So the opposite of 2 2/5 is negative 2 2/5. And it can be written as a negative 2, what we have up here, a negative 2 plus a negative 2/5. Okay. Rewrite each mixed number as the sum of 2 signed numbers. Okay, so you're just rewriting negative 9 5/8, just like here we had negative 2 and 2/5, and we rewrote it as -2 plus a -2/5. So you're going to do that with each of those. Pause the video. Take about 2 minutes, 1 minute to do that. Okay, so you should add -9 plus a -5/8, -2 plus -1/2, and then 8 plus 11/12. In exercise 3, represent each sum as a mixed number. So now you're taking what you had in example 2, your answers in example 2, and you're going back to what it was originally. So go ahead, pause the video, and take a minute to do that. Okay, so on the first one, you should have had -1 and 5/12, B 30 and 1/8, and C -17, whoops, and 1/9. Okay. In exercise 4, you are going to pause the video and try it on your own. Let's make sure we have our equation set up correctly first, though. So he lost 10 pounds. So this is representing -10 pounds. By winter, he gained 5 1/8 pounds. So plus positive. Represent the situation with an expression. So your expression was -10 plus 5 1/8. What is the overall change in his weight? Okay, so go ahead and pause the video and try that on your own. Okay, so your answer would have ended up being -4 7/8. So let's do that. We can do -10 plus 5 plus 1/8. So we're just separating that to add the opposites. So the sum of the opposites is the opposite of a sum is the sum of its opposite, so we're separating it. Okay, and then we have -10 and +5, so those are different signs. So you subtract it and you keep the sign of the greater absolute value, so therefore your answer is negative. So it's a -5 plus 1/8. Okay, and then here these signs are different again, so therefore you're subtracting, and you're again keeping the sign of the greater absolute value, so it is going to be negative. And so if we have -5 plus 1/8, so we're subtracting, we're taking 1/8 away, we're left with a -4 7/8. You could draw a number line to help you to be able to see that. So Mr. Mitchell's weight dropped by 4 7/8 pounds. So like I said, you could draw a number line to help you to represent that like we did in 7. So we had -5, and then we're breaking it into 8. So 1, 2, 3, 4, 5, 6, 7, and then -4. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. And so you're starting at -5, and you're going to the right 1/8. So that puts you right here at -4 7/8. Okay, in exercise number 5, Jamal is completing this math problem, and he wants to get to a single rational number, and he does it by these steps shown below. We are asked to justify each of Jamal's steps and then show another way that we could solve this problem. So to the right, all of the words that I have are the different steps. They are not in order. So what we're going to do is one of two ways. You can either start looking at it and try and match them up, but you're going to copy this little section. You're going to copy this right here into your notes neatly. And then we are going to, you can either number it, 1, 2, 3, 4, each step, and then we'll do the corresponding numbers. This is just examples, don't put it. Okay. Or if it makes more sense to you to draw the lines, then that will be able to be the way that you can do it. But currently, just copy down the steps. So pause the video and copy down. Okay, so to find our steps, we need to look at what we had and then what we have now. So right here, we have -5 and 5/7 plus 8 minus 3 and 2/7. So this is still the same. This is still the same. The 8's still the same. What changes is right here. We changed it to addition. So, and then we did the opposite. So here's our step. Subtracting a number is the same as adding its inverse. Okay, so from our next step, let's see what happened. So this is still the same. Oh, there we go. We have a different order. So when we change the order, that is applying the commutative property. The commutative property changes the order of something. Okay, next, let's see what's happening. Okay, next we can see that the -5/7 5 and 5/7 has been separated, and so that's what we learned in this lesson, that the opposite of a sum is the sum of its opposites. Okay, and in our next one, let's see, so this is the same and it changes right here. So the order changed, and so that is, we are going to be applying the commutative property of addition. So we changed the order again. Okay, so we had written that twice. Next, let's say we have -5, that's the same, plus a -1. So that's the same. Where did they get the -1 from? So -5/7 plus -2/7, same signs, you're adding. So 5, 6, 7. So -7/7 gives me 1. So Jamal did the addition right here first, which is the associative property, that we can regroup them. So he grouped those two together to add them first. So our next one, we have -6 now. And so we can see they're putting these two things together, which have the same signs. So we have to add, and we keep the sign of the greater absolute value. Next, we see -6 and -3 are now gone because we were, again, adding the same sign, different signs. Add and keep the sign of the greater absolute value. And then finally, -1 is because the two were different signs, so we subtracted. We kept the sign of the greater absolute value. Okay, and I added the numbers in there in case you wanted to do numbers instead of lines. So 1 goes with 1 each step. And then it says, then show another way to solve the problem. So these steps are not necessarily, we don't have to always go in the exact same order. So you might change order, but you know that your answer should end up being at -1. So go ahead and pause the video and try it Another way, maybe switch some of those steps. Okay? Okay, so this would be a good one to just kind of practice the different laws, properties that we have in math that you can do. So the first thing that I did is I changed it to all addition, because once I have it as all addition, I'm allowed to move it. So that was why we were looking previously in lesson 5 on the rules of subtraction, so we could see if we changed it to all addition, we're allowed to kind of move it around. So then negative 5 and 5/7 plus a negative 3 and 2/7 plus 8. You should show each of the steps and not try and do multiple steps in one thing. Oh, that's supposed to be negative. There we go. Okay, so then we have negative 5 and negative 3, which gives me a negative 8. So that's the separating. Honestly, let's do that more out of this step as a step. So negative 5 plus negative 5 and 5/7 plus a negative 3 plus negative 2/7 plus 8. Remember, you can put the parentheses to help it to just look differently. Okay, so then I'd say negative 5 plus negative 3 plus negative 5/7 plus negative 2/7 plus 8, which gives me negative 8 plus negative 1 plus 8. And negative 8 and positive 8 is 0. So 0 plus a negative 1. So that was the associative property because I was regrouping it. Granted, they're not next to each other, so I should have moved them first. And that gives me a negative 1. Okay, so there are multiple ways to do this. The more practice that you get with it, the better off you're going to be.